In this video we're going to go over the solutions to Lab 7. Now I'm not going to have a copy of the Lab 7 open during this video just because I need to see the screen as I'm working, but it might be useful for you to have that up as we go. But let's start at Lab 7a. For Lab 7a, what we're asked to do is we're given an ARGB pixel fit into a word, which that means is that the first 8 bits represent the blue, and then the second 8 bits represents the green, next 8 bits represents the red, and the most significant 8 bits represents the opacity. So we are asked to blend two colours, and what we're asked to do is to add each channel, that's the red, green or blue, together with the corresponding channel from the other pixel, and divide by 2, and then put that into a final word where the opacity is set to 255, which is to say to have FF in that opacity channel. So yeah, the lab sheet might be more useful to you than me trying to explain it, so let's just have a look at how we would do this. Now we're asked to write a subroutine and we're asked to follow the MIPS calling conventions. So first things first, what we should do is come up with a label for this, and it should be called blend ARGB because that's what we're asked to do, so that's always a good place to start. Now I'm going to load two immediate values. I'm going to load one into T0, and that's going to be the value of OX, OO, FF, OO, OO. And then I'm going to load into V0, value of OX, FF, O. Now, the first value is to allow me to, because I'm going to set up a loop, so that's going to allow me to grab out get the red channel, and then when I shift it, that'll get the green channel, and then I'll shift it again and I'll get the blue channel. The second value is there to set the opacity to be 255, so that's an FF in the A channel. So let's see what we do. So let's set up a loop. And what I want to do is AND value in A0 with A0. Oh no, I don't want to store that in A0, let's store that in T1. But we're going to AND the value in A0 with the value in T0. And this will get channel from A0. And then I'll do the same for the second one. I'll put that in T2. And that should be A1, but it should still be T0. And that's get second channel. Now I have them both, so I want to add them together and then divide by 2, so let's do the adding. So let's just put that in T1 to cut down on our register use. So get sum and then divide by 2. I'm just going to use shift right logical by 1, and this is div by 2. Now you can use the div instruction if you want, I just prefer to use shift right logical, so that's what I'm going to use for this example. Okay, so I found the average. So what I want to then do is I want to OR this AND this value, because I don't want it to overflow on either side of the channel it's representing. So if this is representing the reds, I don't want it to flow over into the A and the G channel, or the opacity in the green channel. So what I'm going to do is I'm going to AND T1 with itself and the value OX. Oh no, actually I should just use T0 because I'm going to shift that. So make sure value stays in channel. If I could type. Okay, and now that I have that, what I can do is I can OR this value with the value in V0. And that's us more or less done. So then we add to blended pixel. And so far we're happy. Okay, so now what I want to do is I want to set up the loop so that next time when we go back to the start and go through it again, we'll get the next channel. So what I want to do is shift right logical, the value that's in T0, and I want to shift that by 8, so we'll move it a byte down so that's in the next channel. And I want to say if this is branch f equal to 0, so if T0 has gone to 0 because I'm shifting it down, so it eventually will go to 0, then I should just go to the end. Otherwise, I jump to loop. Okay, and then I need an end label. I've not used anything fancy here, so I can just do jump register back to RE. Now, hopefully that'll be me set up, so let's assemble this and hope I don't have any errors. It's always very possible I do. Nope, luckily not, and let's run it and hope that we pass our tests. So there we go, 5 out of 5. So that's Lab 7a. So let's now have a look at Lab 7b. Lab 7b I think is a bit trickier, but we're asked to, for each channel, find the value or use this formula to get each channel's value. So one thing that would be easy to mistake here is to think that this is going to be the actual solution to this. This is just the number that you need as the word, but this is actually for each channel, so you could say this is y, and you could say that this is going to be for some channel that looks like FF in the top, and then we have y, and then we have y, and then we have y. That is to say, y should be the value for the red, green, and the blue. Shouldn't just be the word in that channel. It's just in case anyone got tripped up there. Okay, so now I'm told that the color is an A0, and I want to set this to be equal to, set the values to be equal to this. So let's, first of all, grey from A RGB. Okay, and so I want to set about extracting the values. I'm going to start off with, let's start off with the red. So let's say shift right logical. I'm going to put this in T0, and it's going to be the value of A0. And I'm going to shift that right by 16. And this will put red into the least significant byte. And it'll allow me to extract it easily, so I can just do and I'm going to put this into T0, value in T0, and I'm going to extract that with OXFF. OXFF. This will get the significant byte. Okay, so far so good. Let's move those comments over just a wee bit. Okay, so now I have that value. I want to multiply by 5 and add it into V0. But currently I don't know what V0 holds, so I'm just going to overwrite the value in V0 with T0 times 5. So this is saying V0 equals 5 times R. So far so good. So now we need to do the same, but for the green channel. So we're going to shift left again, or shift right again, and I'm going to overwrite T0, the value that's in A0, and this time we only need to shift by 8. So put put red or green, sorry, into least significant byte. Okay, and now I more or less carry on as before. So I can do mul of shift T0. I can't just store in V0 this time because there's a value in there, so I don't want to overwrite that. But multiply by 9. Oh no, we need to AND that out, sorry. Let's with OXFF. And this is get green. Oh, it's very angry text, but that'll be fine. And green times 9. And now that we have that green value, we can add this to the value that's in V0. And so V0 equals 5 times red plus 9 times green. So we're getting there. Now we just need to do the blue. Now I won't need to shift the blue because the blue is already in the least significant byte value, so I can just do and immediate. The value that's in A0, I'm going to put it into T0 though, of OXFF. So get blue. And now that I have this, then I need to do the multiplication. I'm just going to shift left for this one, T0. And we're going to shift that left by 1, so B times 2. And then we again just add this to the value that's already in V0. And so our total, so let's just copy this down, plus 2 times B. And now I need to divide this by 16. Okay, so now we have this formula up here, so let's actually just put this in. So we've done most of the work now. Now we just need to do a little bit of thinking about how we get this into each channel. So this should be over 16, and this should have brackets around it. So I don't want to make this any more confusing than I'm sure it probably already is. So there we go. Okay, so now we have the value of y into v0. So what I'm going to do now is I'm going to spread this across the first 3 channels. So what I'm going to do is I'm going to mul value in v0 by the value that's in v0, and then I'm going to use a very specific value that will essentially copy these into the right value, or into the right place values. So I know that I want the top column to be 0, so I'm going to put zeros in there. And then I want a copy of y in each byte value, so each byte position, so the RGB. So what I'm going to do is times it by 1 in that byte, 1 in that byte, and then 1 in that byte. And this will mean that I get that v0 is equal to 0, 0, colon y, colon y, colon y. So we're getting there, we're almost there now. So what we want to do is we want to add, or you could OR, it's entirely up to yourself, but I'm going to use add with the value OX, FF, and zeros all the way down. And this will get me that v0 equals FF, and then colon y, colon y, colon y. And that's us. So now I just want to jump register to the return address, and let's assemble this, hope that I made no mistakes, and see what the test results come back as. So we're okay so far, and there we go. So we've gotten 5 out of 5. I think this one could be a little bit tricky, but I think the biggest step is just understanding this, or these 2 lines here, I suppose, mostly the one above, or the line 30. But as long as you understand this bit to copy it into the right place values, you should be okay. But that's everything for this video. I hope you found this useful. If you have any questions, please do let me know. Thanks.